Happy morning. Happy morning to all. Okay. Today our learning objectives to learn about Arrhenius equation and also collision theory. Arrhenius equation and also about the collision theory. So two questions we have to learn today. So please all of you learn this question. It's a very important question for the board exam question. Arrhenius equation, the effect of temperature on the reaction rate. It's a very important question. Arrhenius equation. Generally, the rate of the reactions increase, the increase in temperature. Okay. There are few exceptions. That is, the magnitude of the magnitude of this reaction increases as the rate is differ for this reaction. As per the rough rule, for many reactions near room temperature, the reaction rate tends to double when the temperature is increased by 10 degrees Celsius. The reaction rate is goes to what? Double when the temperature is increased by 10 degrees Celsius. A large number of reactions are known which do not take place at room temperature but occur readily at a high temperature. Does not take a room temperature but occur readily at high temperature. For example, one of the reaction between hydrogen and oxygen. Okay, hydrogen and oxygen we get for what? Water molecules. Am I right? This reaction takes place when an electric spark is passed. Okay, these are some about the Arrhenius. Anyhow, today our learning to learn about the Arrhenius equation. What is about the Arrhenius equation? That we must know. The Arrhenius equation that relates to the most reactions are vary with temperature. He proposed one of the relationship between the rate constant and also the temperature. One of the equation that is equal to K is equal to AE the power minus EA by RT. AE power EA by RT. That's one of the equation. We have to substitute two rate constant. We are using two rate constant, that is K1 and K2. And about the temperature, we are using two temperature, T1 and T2. This two temperature, we are substituting this equation and we get one value. That is about the Arrhenius equation. Let us please all of you take the note. We can write the equation. So one of the very important question, one of the board exam question. So try to learn this question today itself. And also about the collision theory. This is also one of the very important question. Try to learn this question. Please all of you take the note. Okay, today our learning objectives to learn about Arrhenius equation and also collision theory. About the Arrhenius equation, he suggested that the rate of most reaction varies with temperature. The rate constant is directly proportional to E raised to minus EA by RT. And he proposed a relation between the rate constant and temperature. Here the main proposed that the relation between relationship between rate constant and the temperature. That's the formula. About that, K is equal to AE the power EA by RT. This is the equation. Okay. What's the equation? K is equal to AE minus EA by RT. That's the power EA by RT. Okay. Where A is the frequency factor. What is about the A? A. Where A is frequency factor. Frequency. A is frequency factor. And this R is the gas constant. R is the gas constant. And about the T, this T is the absolute temperature. in Kelvin. Okay, in Kelvin. T is the absolute temperature in Kelvin. And about the EA, what is about the EA? Don't forget that EA is the activation energy of the reaction. Okay, anyhow, here he proposed that Arrhenius proposed that. What is proposed? A relation between the rate constant and temperature. The rate constant and temperature. What is the formula? This is one of the formula. K is equal to A the power minus A by RT. Okay. Here, the frequency factor A is related to the frequency of collision. Okay. The frequency factor A is related to the frequency of collision between the reactant molecule. The factor A does not vary significantly with temperature and hence it may be taken as constant. Okay, the A does not vary significantly with the temperature and hence it be taken as a constant. Anyhow, EA, what is about the EA? EA is the activation energy of the reaction. Anyhow, for this reaction, for this equation, he take the logarithm. Okay, logarithm between the both sides of the equation. Okay, taking logarithm. This is the equation number 1. Equation number 1. We are taking logarithm on both sides. Okay. That is taking logarithm on both sides. On both sides. Okay? On both sides we are taking logarithm. Ln K is equal to ln A plus ln E power EA by RT. You have to take what? Logarithm. Okay. We can written as ln K. Ln K is equal to ln A minus. This time become 1. This time become what? 1. Okay. So minus EA by RT. Okay. Minus EA by RT. Because reason, therefore, ln E is equal to ln E is equal to 1. Okay. So we can be right. We should be take the T from this square bracket. Okay. We are taking the T. Taking T. So we can replace the equation. Ln K is equal to ln A minus EA by R. Okay, don't forget that EA by R, taking the temperature 1 by T is equation number what? Equation number 2. Anyhow, here the straight line equation. What is the straight line equation? Y is equal to C plus mx. The above equation is the form of straight line. Y is equal to mx plus C. Okay, y is equal to mx plus c. The above equation, this equation is the form of straight line. Straight line, that is y is equal to mx plus c. When we are plotting ln k versus 1 divided by t. Okay, ln k versus 1 divided by t, we get a straight line. We get what? One of the straight line and we get a negative slope. Okay. We get a straight line with what? A negative slope. That is minus A by R. Okay. Minus A by R. Anyhow, if the rate constant for the reaction at two different temperatures is known, we can calculate the activation energy. Okay, what's the condition? If the rate constant for the reaction at two different temperatures, two different temperature means T1 and T2, two different temperature is known, we can calculate the activation energy. So we have to write the temperature. What are the temperature and what are the rate constant? Temperature means T1 and T2. The rate constant is K1 and K2. Okay. These are the two temperature. That means from the equation 2, ln K1 is equal to ln A minus EA by RT1. This is the equation number 3. That means the temperature T is equal to T1. T equal to T1. Okay. And the rate constant K is equal to K1. Okay, temperature T1 is T is equal to T1 and the rate constant K is equal to K1. And also at a temperature T is equal to T2 and the rate constant K is equal to K2. Okay, K is equal to K2. Again, we have to write the equation number 4. Okay, by using the second equation. From the second equation, the K1 is over. Then we have to write K2. Ln K2 is equal to ln A minus EA by RT2. This is the what? Equation number 4. Okay, equation number 4. Anyhow. Equation 4 minus 3. Equation 4 minus 3. So first you write 4. Equation number 4. That is, what is the equation number 4? ln K2 minus equation number 3. ln K1. Okay? K2 minus K1 is equal to minus of EA. Minus of EA by RT2. Okay, RT2 plus EA by RT1. EA by RT1. Okay. Okay. Next about ln K2 by K1. Ln K2 by K1. Ln common, we can take common. ln K2 by K1. How do I write? Is equal to the common factor we are taking, that is EA common, R also common. Okay, we are taking EA by R, then 1 divided by T1 minus 1 divided by T2. Okay, the common factor we are taking, that is EA common we take and are also taken, and the different one is T2 and T1. So first we write, that is 1 divided by T1 minus 1 divided by T2. Here we should be take the ln is converted to log by adding 2.303 by multiplying 2.303. Okay, so 2.303 log K2 by K1. Okay, the time is converted, that is natural logarithm. Okay, ln is converted to log by adding 2.303 by multiplying 2.303 by K2 by K1 is equal to EA by R cross multiplication T2 minus T1 divided by T1 T2. Okay, T2 by T1 divided by T1 T2 by cross multiplication. Clear? Have it out. One more step also having. Okay. Have it out this area. So land is converted to log. Okay. Land is converted to log. So multiply by 2.303. So by K2 by K1 is equal to EA by R cross multiplication T2 minus T1 divided by T1. Okay. Clear. Next we can write log K2 by K1 is equal to, this term will become log, okay, equal to EA by 2.303 R, okay, R T2 minus T1 divided by T1 T2. Okay, clear? This is the final equation. This is the final equation. Anyhow, this equation can be used to calculate EA from the rate constant K1 and K2 at the temperature T1 and T2. This equation can be calculated. Okay, this equation can be calculated EA from rate constant K1 and K2 at the temperature T1 and T2 respectively. This is the final equation. Have any doubts from this area? Have any doubt? Okay. Anyhow, you try to write 1 or 2 times. It's a very easy question. Try to complete this question. Okay. Anyhow, this is, I think that this is a very important repeating production question. So kindly learn all of you this question. Have doubt means please call me. Arrhenius equation, very, very important question. Arrhenius. Okay. Our one question is over. Next about we can be learn about the collision theory. Okay, collision theory. Collision theory. The collision theory was proposed by Max Thruds in 1916 and also William Lewis in 1980. What is about this theory? What is about the collision theory means? The theory is based on the kinetic theory of the gas. Based on the kinetic. Gases. This is about the collision theory. Here, according to this theory, the chemical reaction occurs as a result of the collision between the reacting molecule. Let us consider one of the reaction. That means we can write A2, one of the gas A2. A2 gas plus B2 gas. A2 gas plus B2 gas. What is the product? 2AB gas. Okay. Can you write A2 gas plus B2 gas? What is the product? 2AB gas. Anyhow, if we consider the reaction between A2 and B2 molecule proceed through the collision between them, what is about the rate? The rate would be directly proportional to the number of colliding molecules. Number of molecules colliding per liter per second. Okay, that means the A2 and B2 molecule proceed through collision between them. Okay, anyhow, what is about the rate? We have to find out the rate. The rate would be proportional to the number of collision per second. Okay, that means rate is directly proportional to the number of molecules colliding per liter per second. Okay, per liter per second. Anyhow, you should be write the collision rate formula. The number of collision is directly proportional to the concentration of both A2 and B2. That also you have to write the number of collision is directly proportional to the concentration of both A2 and B2. Okay, so you have to write what? Collision rate. Very, very important. Collision rate. Collision rate is directly proportional to A2, B2. Okay. Then you have to, the proportional is changed as equal to, have to use one constant. So collision rate is equal to, we are using one constant that is called Z. Which constant we are using? Z. Okay. A2, B2. Where Z is what? Z is a constant. Z is what? Z is constant. Okay. Next about, what is about the collision rate? You should write the collision rate. For a gas at room temperature, what is about the room temperature? 298 Kelvin. Okay. The gas at the room temperature and at 1 atmospheric pressure. Okay. Each molecule is very, very important. Each molecule undergoes approximately approximately 10 raised to 9 collision per second. When at room temperature, for a gas at room temperature, that is 298 Kelvin and 1 atmospheric pressure, each molecule undergoes approximately 10 raised to 9 collision per second. That is one collision in 10 raised to minus 9 seconds. These are the one word, don't forget that. These are the one word, okay. These are the one word, don't forget. Make it as an important. Okay, anyhow, if every collision results in a reaction, the reaction would be complete. The reaction would be complete in 10 raised to minus 9 seconds. Okay? Okay, anyhow, in actual practice, it is not happen. It implies that all the collision is not effective. Okay. Anyhow, one collision in 10 is 10 raised to minus 9 seconds. Anyhow, but here collision is not effective. All collision is not effective. But anyhow, it possesses a minimum energy. That is called, we are saying, activation energy. Anyhow, in order to react, all colliding molecules must possess a minimum energy. Okay, all colliding molecules must possess a minimum energy. Okay. Okay. All colloidal molecules must possess a minimum energy. That minimum energy is called what? Activation energy. This is one of the important 2-mark question, okay? Very important 2-mark question. What is about the activation energy? What is about the activation energy? All colloidal molecules, okay, in order to react, the colloidal molecules must possess a minimum energy. That energy is called what? Activation energy. The molecule that collide with less energy than the activation energy will remain intact with it. There is no reaction is occurred. Okay, no reaction. Anyhow, the fraction of effective collision. Here we are using a fraction of effective collision. Sum of the effective collision. Okay. Anyhow, previously I told you here that all collisions are not effective. Am I right? All collisions are not effective. But anyhow, a fraction of an effective collision, we are giving one formula, that is F is equal to E minus EA by RT. Okay. Here what is about the EA? I told you that. What is about the EA? Previously I told you. EA is activation energy. Okay. EA is what? Activation energy. What is about the R? What is about the R? Gas constant. What's about temperature? T, temperature. Temperature, Kelvin. Okay. Clear? What's the formula? F is equal to EA power minus EA by RT. Let us calculate the collision factor. One of the collision factor we have to calculate for the activation energy. Okay, one of the problem we have to calculate. Calculate the collision factor for having calculate the collision factor for a reaction having activation energy of 100 kilojoules mole inverse, okay, at 300 Kelvin. That's the problem. Okay. Anyhow, what is the formula? F is equal to E minus EA by RT. Okay. We have to substitute this one. F is equal to E, the power minus, what is activation energy? 100 kilojoules mole inverse. So 100 into 10 raised to 3 joules mole inverse divided by R. What is about R? What is about R? Gas constant. Am I right? One of the constant value 8.314 joules Kelvin inverse mole inverse. Okay. And what is about the temperature? 300 Kelvin. What's the temperature? 300 Kelvin. Clear? So what's the value? F is equal to approximately 40. That is approximately equal to 4 into 10 raised to minus 80. Okay. You should be find out the value. Okay. Out of this is the collision rate. Okay. collision factor, the magnitude of the collision factor F, we have to find out. Anyhow, out of these 4 into 10 raised to minus 80, 18 collision, only 4 collisions are sufficiently energetic to convert reaction to product. Here out of this value, only 4 collision. Okay, this value, out of this value, only 4 collision are sufficiently energetic. How much collision? Only 4 collision are sufficiently energetic. Okay? Anyhow, here a fraction of collisions is further reduced to orientation factor. Okay, out of this I told you that out of this, that is 10 raised to 18, only 4 collisions are what? Sufficiently energetic to convert reaction to product. This fraction of collision is further reduced to orientation factor. Here we can find out the orientation factor means we should be draw one diagram. What is an effective collision? What is the correct collision? Proper collision, and we can be say improper collision. Okay. What are the proper alignment? We can be say proper alignment and also improper alignment. Here, effective collision or ineffective collision. Which are the effective collision, and we have to understand that one. Effective collision and ineffective collision. Okay. First we can be draw. First on the reactant. Reactant, which are the reactant? A. B. Okay, B. This is what? Reactant. This is the proper alignment. Okay, proper alignment. That means we can say the correct form. Okay, correct form. The collision is correct form. This goes to effective collision. A, B. This is the correct collision, effective. Here we get the correct product. Okay, we get the correct product. That means here one of the A, B. One of the A, B. Okay, A, B. Here also A, B. Product. These are the correct form. We can draw the improper collision. That is, we can be saying this is the AA, this is the correct form. Here we are writing the linear arrangement. AA like that. A plus, here also we should be plus, B. Improper alignment. Okay. Here, this is an effective collision. This is an ineffective collision. Okay. Like that we get one of the structure like that. That is AABB like that. AABB. Ineffective collision. That is here AA like that. A plus B. Okay, this is we can be say again this is not a product. This is not a product. Is it product? No, it is only what? Reactant. This is not a product. Like that. Product means A, B. Okay, already I told the equation. What is the equation? A 2 plus B2 gives 2AB. Am I right? That's the equation. But here having, we get what? A like that only. So, it is not a product. So, we can be say, it is an improper alignment. We can be say, ineffective collision. This is the correct form, effective collision. Because we get what? AB product. So, can you say which one is the proper alignment? First one or second one? First one. Okay. So, that is about the what? Orientation factors of the reactions. Okay. Anyhow, there was a small equation also having, remaining some some formulas also. A few more formula. We shall write this formula. The collision theory also somewhat important. Okay. The important question. Try to learn this question. Next one is about the what is the fraction of effective collision having proper orientation given by one of the steric factor. We are using the symbol is what? P. The fraction of effective collision F, that is a symbol we are using F, having proper orientation is given by the steric factor that we are using P. So, rate is equal to, that is steric factor P into F, we are saying the effective collision, okay, into collision rate. Okay, rate is equal to, what is about the P? Steric factor and the effective collision into collision rate. Okay, so that is rate is equal to P into that F can be written as already told you, that is EA by RT. Okay, into one of the constant we are using. What is the constant? That is Z constant. Z, that is A2 B2. We can use the equation number 1. The previous the rate we learned that one, the rate. Okay, that is we are using Z constant, one of the constant. A2 and B2 as per the what? Rate law. As per the what? The rate law. Rate law. As per what? The rate law. So, rate also can be written as K A2 B2. Okay. What is about the K? K is also can be constant. This is equation 2. We have to compare the two equations. We have to compare the equation, comparing equation 1 and equation 2. 1 and equation 2. Then what is about the answer? K is equal to P is at E. Okay, P is at E. E, what is the power? Minus EA by RT. Here also we have forget to use minus EA by RT. This is what? About the final equation. K is equal to minus EA by RT. Can you write the collision theory? Okay. Anyhow, our today portion we learned that the Arrhenius equation and also the collision theory. So I am giving only a small portion for the assignment. Try to learn this question. It's a very important question. Okay. So both the two questions are very important. Collision theory and also Arrhenius equation. from the kinetic chapter. Try to learn this question. Okay. So today assignment. Arrhenius, to learn about the Arrhenius equation. Arrhenius equation. Okay. Thank you all of you. Thank you. Have a nice day.